Welcome back to Pre-Algebra. I hope you had a good spring break. We're going to pick up at the top of chapter 12. Reason for that is sticking with key content as we finish out this school year. So we're going to start with 12.1 today, and we're just going to read through the lesson together, work through the examples so that you'll be in a good place to start your homework. Alright, so we're on page 651, 12.1, polynomials. Top of the page, volleyball. A volleyball is hit upwards from a height of 1.2 meters. You can use the expression negative 4.9 t squared plus 8.1t plus 1.2 to find the height in meters of a volleyball t seconds after it is hit. T represents time. What is the height of the volleyball after 1 second? In example 4, you will see how to answer this question by evaluating the expression. Recall that an expression such as negative 4.9 t squared, comma, 8.1t, comma, and 1.2 are called monomials. A polynomial is the sum of monomials. Each monomial in a polynomial is called a term. A polynomial, like 3x squared plus negative 5x plus negative 2, is usually written as 3x squared minus 5x minus 2. Some polynomials can be classified by numbers of their terms. So what does that mean? So first we have expressions in math, which is just a math statement basically without an equal sign. But we can call those expressions polynomials if there are multiple terms. So what they're saying is they have 3x squared minus 5x plus 2 minus 2. And they're calling this a polynomial. And then they're saying a polynomial is made of multiple monomials. A monomial, mono means one, it is just one part of the expression. These are each monomials. Then a polynomial is the sum of multiple monomials. So the entire expression is a polynomial. The individual pieces are monomials, also called terms. So each of these is called a term. And then the entire thing is called a polynomial. And instead of the word term, you can also use a monomial. So the polynomial is made up of monomials. Mono means one, poly means many. And then it says you can have a monomial, which is just one term. You can have a binomial, which is made of two terms. So if you have an expression that is just 5x plus 1, these two terms put together creates a binomial. Bi means two. And then you have a trinomial, which would just be if you added a third number. So if we say plus x squared, term 1, term 2, term 3, three terms, trinomial. Also a form of polynomial. Polynomial is just like the big header. So a polynomial is just anything that has multiple monomials added together, and then you can be specific. If it has just two terms, you would say it's a polynomial, but specifically it's a binomial. It's a polynomial made of two monomials. 1, 2, cool, it's a binomial. Add in that third one, all of a sudden, 1, 2, 3. This particular polynomial is a trinomial because it has three terms. Alright, example 1. Classifying and identifying polynomials. Tell whether or not each expression is a polynomial. If it's a polynomial, list its terms and classify it. So let's look at number 1a. So example A. We have the expression 7m to the negative second plus 4. And our job is to say whether or not this is a polynomial. If it is, classify it. So it'd be fast to say, okay, yes, it's a polynomial because it's two terms, so it's a binomial. But one important rule to know is that you cannot have fractions in it. Well, I take it back. You can't have a negative exponent is the better way to put it, because if you were to bring this down, this is really 7 over m squared plus 4. And you can't have a variable in your denominator position and have it be considered a binomial. So if you look at A, this expression is not a polynomial. The variable m has an exponent that is not a whole number. It's part of a fraction, so it doesn't work. If we go to B, B is just negative b, and we're asked, is this a polynomial? This expression is an example of a polynomial. The only term is negative b. Because it has one term, it is considered a monomial. So, remember, a polynomial is just made of multiple monomials. Because this is a single term, it can be part of a polynomial, but because it's just one, it's called a monomial. See, we have 3x squared plus 8xy minus 1. So step 1, is it a polynomial? Alright, we have positive exponents, so we're good. Is it the sum of multiple terms? Yes. 1, 2, 3. So yes, it's a polynomial. How many terms are present? We have 3 terms present. Tri means 3, so it's a trinomial. And so yes, it's a polynomial. Specifically, if we had to classify it, it would be considered a trinomial. Let's look at our checkpoints. Number 1, 6x to the 4th minus 5x cubed. Take a second, pause your video. What do you think it is? Alright, looking back at it, we have 2 terms. Everything is being raised to a positive exponent. So yes, it's a polynomial. Because it has 2 terms, it's a binomial. Bi means 2, so we're good. Number 2, look at it. Think about what it is. Alright, we have m to the 3rd minus n to the negative 1st. That should be our first hint that this is not a polynomial because we cannot have negative exponents. So even though there are 3 terms, not a polynomial, it has a negative exponent. Number 3, negative 3a plus 7ab squared plus 2. That is a polynomial because the only negative number we have is negative 3, which is a coefficient. We can have negative whole numbers. We cannot have negative exponents. So because of that, yes, it's a polynomial. How many terms does it have? 3. 3 terms means trinomial. Alright, moving on to the next page. Degree. The degree of a term, so a term again is just an individual number. So each of these are degrees, or not degrees, terms. The polynomial is made up of terms. So this part, this part, this part, they're a term. Negative b is just one term. Then we're just going to ignore that one because it doesn't count. But your terms are just your individual pieces of the expression. They're the things being separated by the plus or minuses. They're just the pieces that build your expression. So how do you find the degree of your term? Again, that piece of your expression. It is the sum of the exponents of its variables. So we're going to look at each of these, and we're going to say, what is the degree of the term? And we're looking at the degree, or the sum of its exponents, ignoring the coefficients. We don't care about the front number. The degree of a polynomial, so the degree of a term is just the individual term. The degree of the polynomial is the whole string. So to find the degree of the polynomial is the greatest degree of its terms. The degree of a non-zero constant, is 0. Constant 0 has no degree. So basically, ignore your constants. Your constants are just your whole numbers or your coefficients. We don't look at them. We're only looking at our variables. So let's look at example 2. We have, for A, the polynomial 5x cubed plus 8x minus 9. And so we're supposed to find the degree of the polynomial, which means first find the degree of the individual terms, and then the degree of your polynomial is just the biggest. So how do I find the degree of this term? Well, it's the sum of its exponents, but ignoring my whole numbers, so my constants that I don't care about, while I'm not adding anything to this x. So the sum of it is just itself. So what is the highest exponent of my variable? Well, the only variable and the only exponent is 3. So the degree of my first term is 3. What about my second term? Well, again, I ignore my 8, it doesn't matter. I'm just looking at what is the degree or the exponent of this x. Everything is raised to a hidden 1, so just because nothing is there, I know that there's a hidden 1 there. So this is really x to the first, so it has a degree of 1, and then I ignore my constants, they do not matter. And so again, I'm supposed to find the degree of the polynomial, not the degree of each term. But I said my first term has a degree of 3, my second term has a degree of 1, the degree of the polynomial is the highest degree of my individuals. So in this case, it's 3. The degree of this polynomial is 3. All right, let's look at b. For b, we have p minus p to the third q squared plus 4q. Oops, q to the 4. All right, so again, I look at each individual term. Term 1, term 2, term 3. And remember, I said you know what your terms are because they're the things separated by your plus or your minuses. So p minus, so p is its own. What's in between the plus and minus? pq, that's its own term, plus 9. So your terms are the things separated by your plus or minuses. What's the degree of p of my first term? Well, it doesn't say anything, so therefore I know it's really p to the first. Any variable by itself is really just being raised to its own power of 1. So p to the first has a degree of 1. And now we said it's super important that you take the sum of all the variables for an individual term. So for this term, I have 2 variables, p and q. P is raised to the third, 2 is raised to the second. I take the sum of them. So I have 3 plus 2 is equal to 5. So the degree of this particular term right here is 5. What is my degree of my third term? Q to the 4. That's just 4. And now the degree of my polynomial is the highest degree of an individual term. My highest degree is 5. So for b, the degree of this polynomial is 5. All right, let's look at our checkpoints really fast. Number 4, we have 8x to the 4th minus x plus 1. What's the degree of your first term? Well, it's just the degree or the sum of the degrees of your variable, so ignoring that 8. So my first term is 4. My second term is just minus x. Anything by itself is raised to a power of 1. So its degree is 1. So I'm comparing 4 and 1. 4 is bigger than 1, so the degree of number 1 is 4. And you just do that all the way down the rest of your checkpoints. All right, standard form. To simplify a polynomial, combine like terms. Remember that like terms are identical. Like terms are terms with identical variable parts, such as 8ab squared and 3ab squared. A polynomial written in standard form, if it is simplified and the terms are arranged so the degree of each term decreases or stays the same from left to right. Okay, what that means is sometimes you'll have a polynomial where they haven't added together all their like terms, and it's your job to add together your like terms to be able to simplify it all the way. What does it mean to add like terms together? 2 numbers are like terms if they have the same variable and they're raised to the same power. So it's not good enough for them both to have a p. They have to have identical p's. This one has a q, so it's not the same. Or it's not good enough if they have the same letter, x and x, but they're raised to different exponential values. X to the third is not the same as x to the first. You cannot combine it unless it's the same variable raised to the same exponent. So let's look at example 3. m squared plus 5, negative m squared plus 5, plus 2 times m to the 4th, or 4m, not that, times 4m plus m squared. And our instructions say, write this polynomial in standard form. So that just means simplify it, bring together all of your like terms. Since we have no equal sign, we're not solving for n, we're just trying to reduce this expression. Put all your like terms together, and then just leave it as that. So if I'm looking at an expression like this, step 1, according to PEMDAS, parentheses exponents, is I have to address my parentheses first. But notice I have 4m plus m squared. These are not like terms, I cannot add them. Because this is m and this is m squared, they're being raised to different exponents, can't add them. But I can multiply using the distributive property. I can take my 2, and I can multiply them. Multiplication does not require like terms, addition does. So after I multiply them, rewriting, I have negative m squared plus 5 plus 2 times 4 is 8m plus 2 times this hidden 1 on the outside is just 2m squared. Now my job is to look to see if I have any like terms, and if I have like terms, combine them. The only set I have is this negative m squared and 2m squared. There's a hidden 1 in front of this, so it's really just negative 1m squared. And because I have m squared and m squared, same variable, same exponent, they're like terms and I can add them. Negative 1 plus 2 is just 1, and so that just becomes m squared because we don't have to write that hidden 1. Those two have now been combined. Because our job is to write them in decreasing order of exponents, that means this one comes next, plus 8m. Notice I'm not combining them, they're not like terms because they have different variable expressions. That's been added, plus 5, that's my last term. And that's as simplified as I can get for this particular problem. I cannot add them past this point. I have no more like terms, and I've arranged it from decreased order of exponents. M squared, m to the 1st, then my constants come last. Alright, let's do one of our checkpoints together, and then you can start your homework because we're going to ignore example 4. Let's look at number 13 together. So checkpoint 13. We have 4a minus 5 a to the 3rd minus, or not minus, plus a minus 3. Okay. So step 1, as in our previous example, is we have to do the distributive property of this 5 to everything inside of parentheses. But this is tricky because we have to ask ourselves, are we distributing a positive 5 or a negative 5? Answer that in your head. Do. The answer is it's a negative 5. Remember, subtraction is just the addition of a negative number. So it's the negative 5 that gets distributed. And now we just rewrite. So we have 4a plus negative 5 times a to the 3rd. There's a 1 in front of that a, so negative 5 times 1 is just negative 5. A to the 3rd plus negative 5 times a. There's a 1 in front of that a, so it's just negative 5 times 1. Negative 5a minus 3. Rewriting there. And now I ask myself, do I have any like terms to bring together? Do I have any other variable that's a to the 3rd? No. So there's nothing else I can do there. So I'm just going to rewrite that starting with my highest exponent. And it has nobody, so I can't combine it. My next highest exponential value is just a to the 1st. And I notice I have 2 of them. I have 4a plus negative 5a. Same variable, same exponent, so I can add those together. But I have 4 plus a negative 5. 4 plus negative 5 is negative 1. So minus 1a, but I don't actually have to write that 1, I just need to write my a. So far I have negative 5a to the third minus a. These have been combined. I have no constants to combine this with, so just write down your minus 3. And you've simplified this expression. That's as far as you can take it. So with that, you may begin your homework. Good job, guys.